In this video, we are going to talk about high-performance liquid chromatography. Now, this high-performance liquid chromatography is abbreviated as HPLC, and this HPLC is a column chromatography. Okay, HPLC is a column chromatography, and it is a liquid chromatography technique. That is, the mobile phase in HPLC is in the liquid phase. Now, in case of HPLC, the solvent, that is the mobile phase, is not allowed to drip through the column under the influence of gravity. Okay, the solvent is forced in high pressure through the column. Okay, so in case of other column chromatography, you put the solvent, then that solvent passes through the column under the influence of gravity. But in HPLC, you don't rely on just gravity. Okay, you force this solvent through the column at high pressure using motors and pumps. Now, this HPLC yields high performance. It has high speed with respect to traditional column chromatography. And why is that? Because in HPLC, the mobile phase is pumped at high pressure through the column. Now, in HPLC, the stationary phase can be solid or it can be liquid. Now, this HPLC function in several chromatographic modes such as adsorption, partition, ion exchange, and size exclusion. Okay, in all these chromatographic modes, the HPLC can be conducted. Okay, so HPLC means that you are pumping the solvent, you are pumping the mobile phase through the stationary phase. Now, that interaction can be adsorption, or it can be partition chromatography, or it can be based on the ion exchange phenomenon, or it can be based on size exclusion. Okay, but the highlighting thing about HPLC is that the liquid phase, the mobile phase, is pumped with the help of a pump at high pressure. And you can use these separation techniques, and you can use them in combination also, okay, during HPLC. Now, if the stationary phase is solid, then that technique is known as adsorption chromatography. And if the stationary phase is liquid, that is, sample is partitioned between the stationary liquid phase and between the mobile stationary phase, between these two phases, if the sample is partitioned, then that technique is known as partition chromatography. So, if the stationary phase is solid, then it is adsorption chromatography, and if the stationary phase is liquid, then it is partition chromatography. Now, there are two variants of this partition chromatography, and that two variants are classified on the basis of the relative polarity of the solvent phase and the stationary phase. Okay, so those two variants of the partition chromatography are normal phase and reversed phase. Now, in normal phase stationary chromatography, the stationary phase is polar and the mobile phase is non-polar. And in a reversed phase partition chromatography, the stationary phase is non-polar and the mobile phase is polar. Now, this reversed phase HPLC is the most commonly used form of HPLC. Okay, that is, in this form of HPLC in which the stationary phase is non-polar and the mobile phase is polar, that kind of HPLC is the most common HPLC that is being used in. So, this diagram represents the typical high pressure liquid chromatography. Okay, so this is a gradient controller, then there is a pump system, then there is this component which is there for sample introduction. Then this is how your column looks like, and then there is data output, system for data output, and detector. Okay, so this diagram is giving you an idea about the HPLC. Now the basic components here are the gradient controller, then the high pressure pump, then the packed column, detector, and recorder. Okay, so this is the thing that separates the HPLC from other chromatographic system, that is a pump system which pumps the mobile phase through the column at high pressure. Now in HPLC a computer is also used, and the function of this computer is to control the processing, the collection, and the analyzation of the data. Okay, the computer does the processing, collection, and analyze the data. Now there is pump in HPLC, and what is the function of that pump? Well, its function is to provide a constant and reproducible flow of solvent through the column. Now the pumps which we use in HPLC are of two types: constant pressure pumps and constant volume pumps. After that you have Hplc column, and this Hplc column are made up of stainless steel, or they are made up of glass Teflon tubing. Okay, so this glass Teflon and stainless steel, you can use either of them to make your Hplc columns. Now consider a typical column. The inside diameter of that column which is used in HPLC is 2.1 mm, 3.2 mm, or 4.5 mm if you are doing analytical separation. And if you are using HPLC for preparative applications, then the inside diameter of that column is going to be 30 mm. Okay, so for analytical separation it is 2.11, 3.2, 4.5 mm, and for preparative application it is about 30 mm. Okay, so the length of column used in HPLC can go from 5 cm to about 100 cm, and 10 to 20 cm columns are commonly used during HPLC. Now the parameters which we utilize to describe the HPLC columns are these two, that is nature, type, size of the packing material, and the dimension of the column. Okay, these two parameters describes the Hplc column. Now in all forms of chromatography, measure of column efficiency is given by resolution. Okay, resolution is a measure of column efficiency, and it is just not for HPLC, it is in case of all forms of chromatography. So you measure column efficiency by resolution. Now this resolution of column indicates how well the solutes are separated. Now in HPLC there is increased resolution as compared to classical column chromatography. And why is that? Well, because the adsorbents in HPLC are of very small particle size, and hence they have a large surface area. The smaller the particle, the larger the surface area of the adsorbent. And this is happening in case of HPLC, and that is the reason why the HPLC is having increased resolution. That is the reason why this HPLC is resolving, it is separating the solute more efficiently than the classical column chromatography. Now consider the particle size is smaller, and because of this there will be lower flow rate, and if the flow rate is lower, then that is not feasible for very small GL beads while doing liquid chromatography, okay, liquid column chromatography. Okay, because if you are doing chromatography and the flow rate is very low, then the analysis time will increase, and that is not good for experiment, right? So in HPLC, what we do is, okay, we use a pump to pump the mobile phase through the column, and that is the reason why that thing increases the flow rates. Okay, so in HPLC, the increased flow rates are achieved by applying pressure differences across the column. Okay, you use a pump, and that is how you increase pressure, and that is how you increase the flow rate. And that is the reason why in HPLC you can use adsorbents whose particle size is smaller. Okay, in normal classical liquid chromatography you cannot use small particles because the flow rate will reduce and the analysis time will increase. But in case of HPLC, as you are using pump to increase the flow rate, you can use the adsorbent which are made up of small particle size. So the combination of this high pressure and adsorbent having small particle size are the reason for the high resolving power and short analysis time of the HPLC. Okay, so that's all for this video. Thanks for watching. See you next time.